This is the second part of our review for midterm 1. In the first part, which we did over WebEx, in a WebEx session, we went over problems 1 through 10. And now I will go over the problems 11 through 20. And let's start with the problem number 11. It's a problem in which we are given the rate of growth for a population of E. coli bacteria. And we need to determine the population's weight change on a time interval from t equals to 1 to t equals to 5. T is time in hours since the observations began, and the rate of growth is the rate of weight growth for this colony in milligrams per hour. Now, one thing to note here is the rate of growth is not constant, because if you plug in different values for t in the formula for the rate of growth, we're going to get different values. And in fact, we can see that if we use larger values of t, then we're going to get larger values for r, for the rate. So basically, this equation indicates that the colony grows faster and faster and faster as the time progresses. In order to solve this problem, we need to use the fundamental theorem of calculus. And one way to formulate this fundamental theorem of calculus is to formulate it as follows. If we have a quantity which is changing, and we know the rate of change of that quantity, then we can find the total or net change in that quantity as the integral from a to b, where a through b is our time interval over which we're measuring the change in our quantity, of the rate of change. Okay, so the total change in some quantity equals integral of the rate of change. Why is this applicable to this problem? Well, it's because we are given the rate of growth and the rate at which the weight of the colony is changing, and we want to know the total weight change over the time interval from t equals to 1 to t equals to 5. So essentially what we need to do in this problem is to integrate the rate of change, which is square root of 5t plus 3. We're integrating over time, so dt, and the integral of integration is the integral from 1 to 5. So we integrate from 1 to 5, square root of 5t plus 3 dt, and the value of this definite integral is exactly the weight change in the E. coli colony over this time interval from t equals to 1 to t equals to 5. Now let's look at this integral. Under the square root we have 5t plus 3. We can try to simplify this integral by substituting, instead of 5t plus 3, a new variable u. Right, so basically, since we have some not very complicated, but still more complicated expression than just the variable itself, we can try to simplify the function that we're integrating by making the substitution. In order to complete this substitution, we need to express dt in terms of u. And to do this, we calculate the differential of our new variable u. So take the differential of u. Since u is 5t plus 3, differential of u is going to be equal to the differential of 5t plus 3. And let's remember what the differential of a function is. By definition, it's the derivative of that function. In this case, the derivative of 5t plus 3 multiplied by the differential of the variable on which that function depends, so dt in this case. And since the derivative of 5t plus 3 is just 5, we find that du equals 5 dt. I am going to solve this equation, du equals 5 dt, for dt. In order to do that, all we have to do is divide both sides of this equation by 5, and we get dt equals 1/5 of du. Now we have everything ready to, well, almost everything, to rewrite this integral in terms of u. The only other thing that I will need is to calculate the new limits of integration. I'm going to do this in a second. So let me first replace every part of the integral by the corresponding expressions in terms of u. So square root of 5t plus 3 becomes square root of u. Instead of dt, I will plug in 1/5 of du. I'm done with the integrand part, and now let's work out the limits of integration. So the original limits of integration were from 1 to 5. This is the range over which the values of t change. So t ranges from t equals to 1 to t equals to 5. Since our new variable of integration is u, not t, we need to recalculate the limits of integration. In this case, this is fairly simple. We just calculate the corresponding values of u for each value of t by simply plugging in those values of t into the formula that relates u and t. So into this formula right here. The bottom limit, the lower limit of the integral is 1, so t equals to 1. I'm substituting t equals to 1 into the formula for u, and we get the value of u when t is equal to 1 equals 5 times 1 plus 3. That of course is 8. Next, if I substitute t equals to 5 into the same formula, I'm going to get 5 times 5 plus 3, and that is going to be 28. And so our new limits of integration will be now from 8 to 28. Now we have a much simpler integral in terms of our new variable u. 1/5 is a constant factor in the function that we're integrating now. We can factor it out of the entire integral by the constant rule. To find the entire derivative, it helps to rewrite the square root of u as u to the power 1/2. Because then we can apply the power rule to find the entire derivative of this function. 1/5 times u. The power rule says that to integrate a power of our variable, in this case u, we need to increase the exponent by 1, so the new exponent will be 1/2 plus 1, and then we need to divide by that new exponent, 1/2 plus 1. I do not need to add the constant of integration here because this is a definite integral. We just need to find one antiderivative of the function that we're integrating. And then of course we need to plug in the limits of integration, 8 and 28, and then we will take the difference of those values. Okay, so let's see what we get. First of all, I'm going to simplify our antiderivative a little bit. For the constant terms, we have 1/5 divided by 3/2, so that's going to be 2/15. And then we have u to the power 3/2. We need to plug in our limits and take the difference. And so our final answer will be 2/15 times, open parentheses, 28 raised to the power 3/2 minus 15 raised to the power 3 halves. Now you can use a calculator to calculate what that is. I'm going to use Desmos calculator. So let's see, I have 2/15 times 28 raised to the power 3 halves. But from that, I have to subtract 8 raised to the power 3 halves. Close parentheses, and here we have our answer, 16.737, etc. Since the problem is asking us to express the answer, since the problem is asking us to round the answer to 2 decimal places, we round to 2 decimal places, and we get that the weight change in this colony of E. coli will be approximately 16.74.